All right, good morning, everybody, or good afternoon, depending on the time zone you are in. Welcome to First Line Technologies presentation on the science of post-fire decon. This has been a topic that we have been requested quite a bit to talk about. It's something that we've been working on for quite some time. The science has evolved quite a bit over the past few years, and we're going to kind of present on that today. My name is Corey Collings. I'm Director of Training for First Line Technology. Reggie, can you go to the next slide for me? Today, I have the pleasure to introduce Reggie Norton. Some of you may know Reggie as the Southeast Product Manager for First Line Technology. He does that. But before that, Reggie he's an Army veteran. He had an almost 30-year career in the fire services, notably retiring as a captain of the Mobile Fire Rescue Department there in Mobile, Alabama. A lot of experience. I actually knew Reggie before he came to work at First Line. One of those guys that is always looking for how to advance the best practices and the science when responding to dangerous situations, hazardous materials, working fires, industrial fires. Reggie also has a broad experience working with a wide variety of emergency response organizations outside of the fire service, to include especially a lot of industry and industrial chemical plants down in the Southern Alabama area. Reggie's also an instructor at the University of South Alabama and the Alabama Fire College. So he's a great resource. He's a wealth of knowledge, quite a bit of experience. And sorry, Reggie, could you go back one slide for me? Just some administrative stuff before I hand it over to Reggie. So everyone is going to be muted just because of the number of people we have on the call. Please use at the top of your screen, there should be a Q&A panel, Q&A button. It looks like two little chat bubbles with a question mark. Please put any questions at any time into that Q&A panel. We will set aside time at the end of this presentation and try to answer all of those questions. If we don't get to your question, we'll make sure to follow up with you via email. You will get the slide deck. It will be made available. So if anyone registered for this course and was not able to attend, as long as they register, they will get both the slide deck and a recording. This webinar is being recorded. And we'll try to focus on, hey, these are the takeaways. This is what you need to bring back to the firehouse, what you need to bring back to the department. So without further ado, I'll hand it over to Reggie Norton.
All right. Thank you, Corey. Thanks, everybody, for showing up, and Corey for the hype there. I always try to promise small and deliver big, but they hype me up, so we'll see. But so we don't want to waste anybody's time. We're going to get into this. What we'll cover: the current research, emerging trends. We're going to look at the science. That's the key. Where the evidence stands today in 2026. There's not as much science as probably I would like to have seen, and going back as far, but what we have is moving fast, and we do have a good data set now to look at. Next, we'll talk about the how, right? How are we getting contaminated? What's happening on the fire ground? As best as we can look at the science, we'll determine what we can do to mitigate some of that, right? What's an effective decon? How do we protect responders? What are the advancements in decon technology? Does technology come into play? Is it simple? Is it advanced? We'll talk about all that. And after that, we'll see, hey, how do we turn this into operational practice? What can we do to make this work for organizations? Like, how can you make it work for your organization? And then lastly, strengthening your program. Build this department wide, make it something that is truly usable for the folks in the streets, because they're the ones that are going to matter the most for this. They have the biggest bite in this. All right. So here's the why, the kind of so what. Firefighting is a known carcinogen. In 2022, WHO and the IARC, they're looking at data, decided that firefighting was going to be group 1 carcinogen. That puts it in the same area as secondhand tobacco smoke and asbestos, right? So from that chemical exposure, there's cancer risk. It's a chronic thing, right? It's not a single acute exposure. It's long duration. It's chronic. But because of that, we're seeing the chronic effects. What can we do to help combat the contamination is Decon. No matter what, you learned it in your A&O, Decon is exposure control. When we're looking at dose, time is huge. When do we decon? Those are all important. So we do have a data set now. We have science, and the science is actionable. There are things we can do. There are efforts we can put forward that are simple that will make a difference. For me, the big thing that I look at is, you know, I've always tried to leave it better than I found it. I'm not running into burning buildings anymore, but I still stay closely engaged with those people that do. One of those things that I consider here, like for me, the big aha and the big takeaway is this. Everything we do in the fire service is for them. If you're in the fire service, you know what I'm talking about. Over the last couple of decades, we've seen some changes with that. There's a couple of things we do for us, right? The things we do for you guys and we do for each other. Rapid intervention is one. It's become part of the plan. And now with the data we see here, this is one we do for us. High levels of cancer, we want to turn that around. So make this something that you do for you. Make sure you do it for your men and women that are out there in the streets. And this is the thing we do for us moving forward. That's my takeaway from it. I want to make it better for the responders. All right. So we'll talk about some key contaminants, like what are the things that we're seeing the contamination? What are the products of combustion that we can measure and that we know are carcinogens? Well, these PAHs is polycyclic aromatic hydrocarbons. Why do they matter? You know, which ones matter? BAP is the one that we look at the most. It itself, you know, when we talk about the fire ground, it's a group 1 carcinogen. So PAHs are the classic chemical that we most commonly find in smoke, and BAP is one readily markable. We can mark it, right? We can see it. So it's kind of the benchmark. It's what they use in the NFPA 1850 standard to take care of and to be able to mark how effective is our cleaning there, right? It's one of those we can look at. So the thing to consider here too, those BAP, most common, but PAHs are found in every fire. The pot on the stove, the dumpster fire, the structural fire, the house fire, all of those things are going to produce those PAHs. So they are markable things we can look at. They are carcinogens, and we can reduce those levels. So that's why we're going to look at the PAHs and why that's an important part of the study and what we go through. All right, so when we talk about contamination and particularly the PAHs, how are they getting in? What are the issues? What are the routes of exposure? You've seen this before. We've talked about it in our A&O. If you're a technician, you get it there too. Dermal, it'll pass through the skin. So the soot binds to the skin. Those combustion byproducts, they permeate, right? They get inside the bunker gear, but they also pass through and get to the skin. And hot, sweaty skin, pores are open. That's where we're going to see the highest absorption rates. Again, these are things that are chronic. It takes a long time. It takes multiple exposures, you know, over a full career for them to start seeing the action. But when we do, we're seeing chronic effects, right? Just the carcinogen. So some of the things to look at when we talk about the dermal, the neck, the jawline, some of those places where we have highly vascular areas, close, you know, vessels close to the skin. And those are some of our least protected areas when you think about it for that type of contamination. Next is inhalation. You know, inhalation is a very efficient way to bring things into the body. That's why we smoke tobacco or, you know, inhale other substances that get you going, right? So inhalation is a very efficient way to get things into the body. There's a simple solution to the inhalation side. Wear your SCBA. That if that hasn't been a part of your culture in the fire service at your agency for the past 20 to 25 years, that's something that should start today. That's an easy fix. But we got to be mindful of when we wear the SCBA. Anytime we're around these byproducts of combustion, we've got to have that respiratory protection on. All right, it's got to be a must at this point. It's not easy to do. It's not easy to maintain. but it's one of those things that has to happen. That's got to be part of the culture. Ingestion should be the least likely, but it happens, right? First thing we want to do when we come out of that fire and start getting gear off, we want to get something to drink. Some folks need to get a dip, right? Gonna calm things down there. But we want to avoid that until we have at least decontaminated our hands really well, right? We want to wear gloves whenever possible for that. Not in the fire, but post fire. Latex gloves can be a big help there. But we need to clean the hands early and clean them often. And that'll help from that ingestion side. That's a work site. That's a workplace, work practice thing, right? We just need to take care of that. But that is a route of entry that we have there. All right. So current research, emerging trends. This is the science of post-fire decon. If we look through this, you can see, and even as late as 2010, the IRC, that's that WHO organization, had listed firefighting as a group 2B, which means, hey, this stuff could possibly be bad for you, but we don't have the data set. And so it's only possibly carcinogenic. So in 2017, there was an NIOSH, UL, IFC that quantified and started to do a study that looked at gear and skin contamination and started getting the data set. And this was the early proof that on-scene decon was working. So based on some of that data set and other data sets that were out there in the science working, IRC reclassified firefighting to a known carcinogen in 2022 to a group 1. So when we talk about the data and the science from 2022 to today, we're 4 years in. There's a lot of data, a lot of good data out there, but it's still fluid. There's still things that are missing, right? We don't know, is it in the fire that we're getting the issues, that we have the contamination? Is it post-fire? How much can we do to reduce it, right? Those are things we'll see in later data sets. We do know rapid effective decon will reduce those PAHs that are carcinogens. Now, I'm not a smart guy. I've run into burning buildings for 29, 30 years of my life. I'm smart enough to recognize that if I reduce those contaminants and reduce the time, I'm reducing the dose. And with that, I'm going to reduce those instances of cancer in the fire service. Hopefully, that's what the data will prove out, but it'll take a while to do that. Then in 2025, NFPA, last year, they strengthened that 1850 standard, and that's the care and maintenance of the bunker gear, the cleaning, right, of the bunker gear, how we treat those protective items that we have for the firefighting. How do we reduce the ability for those to show those carcinogenic and those chronic effects, right? So there's been a change in the fire service over the last 10 to 15 years of dirty gears not, that badge of honor like we think it is. And I'm glad to see that change. I think it makes sense. I bought in pretty early on that because it just made sense to me. But seeing that formalized into an NFPA standard to where we look at how do we clean, how are we looking at the facilities that clean our gear is vitally important. And so that NFPA 1850 laid out some standards, laid out some measurement tools that are available. All right. What did the current data find as we're looking at this? And this is particular to the fire ground, like where's the contamination? Who's the most heavily contaminated? So post-fire skin contamination, and specifically the hands, it's going to vary by assignment. The firefighters closest to the unburned, the not free burning side of stuff where the smoke and those particulates are going to carry the most contamination on their hands. Search and rescue, 226, fire attack, 135, other positions, 10. So we see some exponential, 14% almost for fire attack, 22 times more PAH contamination of the hands of search and rescue firefighters than support position. You know, if you're attacking the fire, you probably got your hands on the hose and the nozzle. If you're searching, you are searching, right? You're hitting those surfaces. So something to think about for those guys that are, you know, if you're on a ladder, you're on a rescue, you're on a squad, your primary job is search, then you need to pay attention to your hands. But even the fire attack, it's exponential, right? We need to be paying attention to that. But that's just where the PAHs are showing up, even inside the bunker gear. All right, so we put this slide in. We know the PAHs are there. PFAS is something we get a lot of questions about. And is it the gear, right? PFASs are in the environment. They're everywhere. And they make things work better. They make the fire gear more water resistant. But typically we're going to see the higher levels of PFAS built into the gear on your moisture barriers and your water repellent outside finishes on those aramid fibers, right? Those are all going to be where the PFAS are at. So we do know PFAS can migrate out of the firefighting gear as loose threads and dust, and that happens from abrasion. That happens as it starts to heat up. So can we say definitively, or is there a plausible route of exposure dermally and inhalation? Again, the SCBA takes care of all of that inhalation hazards. But is it plausible that the gear is causing an issue? Yeah, it's plausible, right? More than likely, if we see higher levels of PFAS in firefighters in their blood, these forever chemicals, it's going to be more than likely from the firefighting foams and those wetting agents, right? Because it's freer. Here's the honest breakdown. PFAS science is still evolving. You know, you want to look at it, look at those claims, treat them like they need to be treated, document everything for future. As data comes out, we understand, you know, as data gets better, we can build those sets. But there is a move towards PFAS-free ensembles. They may not work as well as what we have now. We don't want to give up what we've gained in the dexterity and agility department and protection piece of our gear to make the firefighting more dangerous for something that we're not sure if it's truly contaminating us. So, you know, is it possible? Yes. Is it the primary source? Probably not, is what the data is showing there. Okay. So we talked about the 1850. So last year when the 1851 and 1852 were combined, we brought that together in 1850. It was a standard that was designed for fire departments to look at how they are treating the gear once it's acquired, you know, after we've done our PPE selection and we come up with the gear. How do we take care of that gear? One of the things that addressed was ISPs, you know, how do we use an outside source? So cleaners, the different detergents that we use, there's tougher verifications. We need to separate clean and dirty. We need to have documented programs for inspection, repair, service life. We also need to have operational guidelines that talk about doing decon immediately in the field, right? Let's not wait on that. That was another big piece that comes out. There is recommendations for optional PFAS and PAH testing of the gear by an ISP after its service. So that's something to look at there too. So that NFPA 1850 is that the things that were brought in there are important, and it's supported by the data that we're seeing. So when we talk about our cleaners, right, or our detergents, NFPA asks, you know, and lays out compatibility, like what should they do? How do we become compliance and compliancy for that? So the biggest thing is pH in a safe window. We want to see that 6 to 10.5. Anything above that, and we start to get into the caustic range, most detergents that you're going to see, laundry detergents that are out there, typically run in the 11 to 11.5 range. So they're not suitable for the bunker gear. So that's something we see there is, you know, are we picking a detergent because it smells good and we like it, or are we picking a detergent because it's going to be safe and protective of the gear? We want to have material compatibility. Most of the aramid fibers are the same family for most of the bunker gear that's out there. The moisture barriers, there may be some difference in the thermal barriers, but for the most part, we're seeing the technologies are the same in those textiles. We want to make sure there's something that doesn't degrade the shell, right? We don't want to degrade the moisture barrier. We don't want to degrade the reflective trim. So no chlorine bleach, no harsh solvents is another thing they're looking at. The next thing was the evidence base. Hey, does it lift PAHs and soot out of the gear? Is it removing some heavy metals, right? Are these things that we can quantify and verify? And it also adds that optional PFAS and PAH testing. If you're going to test, you know, we want it to meet certain standards. So one of the key things here is compliant versus approval. If you're seeing an NFPA approved product, that's not true. Be wary of something that says NFPA approved. NFPA is not approving anything. They're laying out guidelines. They're laying out what criteria these detergents and cleaners need to meet. And so those detergents have to be NFPA compliant. And that's something for the manufacturer. That's a manufacturer's claim there. This is NFPA compliant. It's not an NFPA stamp of approval, right? There's no NFPA stamp that goes on any of that. With that being said, ask for data, ask for references, ask for efficacy, right? We want to see the data set. At the very least, making sure it does say NFPA compliant. But if you want to dig down a little bit deeper, and I recommend you do, you look at what is that true pH, right? Are we pushing the upper limits of that scale, or are we falling in that neutral area? How does it affect bunker gear? What does my bunker gear manufacturer recommend? Those type things are important to look at. But compliance, not approval, is key there. We want to be sticking with that compliance piece. All right, we talked about the science, you know, where we are today, how we got there, really fast moving, short time frame, it seems to me. But now we want to talk about the contamination. How's it moving on the fire ground? How does it get beyond the fire ground into us? And what are those chronic exposures that we're seeing? So here we've got kind of a chain, right? And we start at the fire ground and we end at the home. The thing that I think is important about this slide, and the strongest piece, is if we think of this as a chain, every link is an opportunity to break down that contamination risk. We talked about time. Dose isn't just how much. Dose is how long something sits there, given the ability to affect, right? So with that, every opportunity to break a link in that chain of contamination is huge. We need it to start on the fire ground. We're going to show you that data set that talks about early decontamination, how effective it is, what those numbers look like, and bring the science to bear, but it just makes sense. But on the fire ground, we've got those combustion byproducts. That's where the PAHs are living. That's where they're generated. And that's how we pick them up. They're going to get into, obviously, on the turnout gear first. Until we come up with a fully encapsulating turnout gear, which I don't think I ever want to wear that, but until that comes out, there's the permeation that can happen there with the skin, but the turnout gear is going to get it first. There's the ability for absorption and transfer from the turnout gear onto the skin. That's something to think about. So those first three are not shaded. Those are the three that we can greatly affect on the fire ground. Right? Those are the ones, if we can stop in one of those, break one of those links in that chain, or all three of those, we're going to see huge success in limiting the amount of PAHs and what they can do, and hopefully limit the amount of damage they're doing to us as responders in the fire service. The next three pieces deal with the chronic side, but things we can do that are more of a housekeeping thing, right? dirty versus clean cab, the apparatus cab. Do we want that gear sitting in that cab off gassing for a long length of time? No. If we're riding back, I go back to the days of not taking, but jumping back on the truck, pulling the bunker pants down around the boots and just sitting there in the cab and riding back like that because I didn't want to put my feet back in wet socks into the boots or pulling socks off and things like that. And how bad was that to be sitting right on top of the gear, crumpled up over us, for the ride back. So that's something to think about. The clean cab is a concept that's out there. It makes sense. We'll talk about that in a little more detail. Coming back to the station, right? Surfaces and living spaces. Right? If we don't allow the contaminants to get back to the station, then we don't have a big an issue in the station, right? And lastly, the link in the chain that definitely has to be broken is no matter what, you break that link so you don't take it home, right? We signed on to take the risk. We shouldn't expect our families to, so we want to make sure we break that link. The cool thing about the chain concept, though, is we can break that link at any point, right? The more effective, the earlier we do it, the more effective it's going to be. But breaking the links of the chain are important. All right, we'll dig down into the clean cab idea versus dirty cab and just a little bit here. But we know these materials are volatile, right? That means they're going to keep evaporating from that warm gear long after the fire's out. And when we say fire's out, I'm not talking about when, that command piece gets on the radio and tells your dispatch, fire alarm, radio, whoever it is, hey, the fire's under control or the fire's out at this time. We're going to be overhauling. We're doing this. That's not truly fire out. That's not, harmful products of combustion still hanging around without a doubt. I'm talking about from when you pack up, you make that last pass through, you're still collecting those products of combustion. So we know 35 minutes post fire before those levels start to even come close to falling. So field decon is important. It's important for getting products off the skin. It's important for getting products off of the bunker gear, the heavy contamination. But some of those volatiles will continue to do. Now, we can talk about that. Corey and I had a conversation about that pretty recently about the cover up. Can we apply things that will help even after we've done the cleaning that we leave on the bunker gear that will help retain some of that. I think there's some validity to that, but the data is just not in yet on that. So the clean cab, contaminated gear goes into enclosed cab. If we bring it into our enclosed cab, we're breathing that stuff in the whole ride home. It's permeating inside every piece of permeable material inside that apparatus. So every time we get in that apparatus, we're getting that chronic exposure, right? It's going to soak into those areas that are in there. That's what the PAHs do. So they're going to hang around. So ideally, we don't want to put the gear back into the apparatus. Sometimes we have no choice. If we're going to do that, we need to bag it. If we can, we want to isolate it, transport it separate from the crew where possible, right? But be mindful of it, right? If you can bag it, separate it, do as much as you can. Keep your SCBA on as long as possible through overhaul. Don't carry the fire ground, home in the cab. Don't carry it home inside yourself. So I like the idea of the clean cab. Another concept there is, back at the station, let's make sure we're doing what we can to clean the cab out. Let's get any gross contaminants that are in there out of the cab as well. We don't want those hanging around through that whole shift. All right, so we've talked about the data, the carcinogenic effects. We've talked about the PAHs, and we've talked about, what are some things we can do. So what actually works? What is an effective decon and what truly protects responders on the fire ground? So there are 3 levels of decontamination: preliminary exposure reduction, firehouse cleaning, and advanced cleaning. The preliminary exposure reduction, PER, and this is something that I've seen a lot of out of the IAFF. I'm so glad to see at least some layout of, hey, this is how you should conduct it, right? These are things that we need to look at. So that PER, on scene, on air. And guys, we're not talking huge technology here. We're talking soap, water, and wipes. This is the single highest yield step that we have to break that chain. I've got another slide that'll show that, right? I'm going to show you that data, that science piece, and that number there. The number should mean something to you. If we're not doing this on scene, that needs to be part of the culture that we put in place. Next is the firehouse cleaning back at the station. Machine washing per spec. Are we putting things into an extractor? Do we have defined schedules for our gear to be cleaned no matter what through advanced cleaning? There's a difference between going in the extractor and going to an ISP for advanced cleaning. But we need to have that on a defined schedule. And after every fire exposure, this stuff needs to come back. And we need to be thinking about all of it. The hoods, everything that's around your head, your neck, and those areas. We talked about the high susceptibility. Those need to be laundered just as much as the gear, right? Just as much as that coat. We need to be taking special care of those. And then that advanced cleaning piece, they're a verified service provider. We call that an ISP. That's an independent service provider. They're going to handle heavy or unusual contamination. If we do the suggested piece and look at efficacy there to where they're testing for PFAS and PAH at the end of it, then we know we can validate that, right? And we can meet certain benchmarks or the required benchmarks. It should also be done periodically. Go back through your guidelines and your SOPs and see, do we regularly require people to have their gear cleaned? Even if they're not doing a good job of it, we can at least start breaking that chain. And again, every link that we break in that chain is another piece because of the chronic effects of this stuff. It's not acute, it's chronic, it's long-term. All right, so here it is in two solid numbers. On-scene decon works, 85% reduction in PAH contamination on turnouts. That's huge. That is the easiest link to break, and it's probably the most effective. All right. 54% reduction in pH contamination on neck skin using wipes. That's another piece there. The hands, the neck, the face are what we've really got a key on the fire scene. Once we've cleaned those areas, if you could wear latex gloves after the fire is out, during those operations where you're cleaning up, picking up, handling the gear and things like that, latex gloves, we've got them on every truck and they're on every scene. They should be used. One of the things I will mention here, though, when we talk about wipes, we want to avoid alcohol-based wipes. Any alcohol-based wipe is going to increase skin permeation. So instead of reducing the contamination, we're going to help it pass through the skin and pass through that dermal layer. Your body has that built-in dead layer of skin PPE that's there. That's a natural thing. We don't want to exclude that or break it down by using alcohol-based wipes. So look, just like the detergents we're going to talk about, the cleaners, pay attention to what wipes we're using. We want to make sure we stay away from alcohol wipes. We don't want to push stuff through the skin. We want to remove it from the skin. There's probably some evidence of some dry wipes being highly effective as well, but the data set's not truly there on that either. So we'll get to that. Here's the thing though, simple beats nothing. If 85% reduction on the scene happens immediately, that's a huge win, right? That's the biggest win we can get. And the key there is most departments, I don't know about most, there's a trend, right? It's gotten better, but how many of you still wait till you get back from the scene to clean up, right? Through most of my career, that was the common piece. Very little on-scene cleaning. Mostly it was when we got back to the station. If we can remove 85% rapidly, that's a huge win. Don't skip step one and go for step two. Start implementing on scene, right? That needs to be a priority. If that number doesn't mean something to you right there, that is huge to me. Okay, we need to decon the firefighter, not just the gear, right? The gear is important, but what is the gear there for? Is to protect us, right? We wear the gear so we can go inside and be in close proximity, and do our job inside that fire. We go get folks out. So the key there is still protect the firefighter. This is the thing we do for us. Never forget that. Very few things we do for us. This is one of them. Keep on air, obviously. Through overhaul, gross decon, vapors are still off-gassing from the gear. Until you are out of your gear completely, we're going to see those PAHs present. Gross decon the gear. Rinse, soap, and scrub the ensemble before doffing. Knock down 80% plus. We saw that 85% number of surface contamination. Now, doffing. Doff deliberately, right? If you need help, get help. If it makes sense to have someone help remove their coat, have those people that are conducting that wash down. They should be wearing nitrile gloves anyway. All right. As soon as you can, when you're going to handle that gear, clean your hands and put on a set of nitrile gloves. Then we'll bag it for transport. Again, if you're wearing your gear and you don't have respiratory protection on, you're in that area of PAHs. So once we have our gear doffed, immediately go to the skin, right? Those areas we want to hit are the neck, the jaw, the hands, and the face. That should happen definitely before rehab. But even if you're going back in to pick up, right? We just got to pick up tools. We got to pick up hose. We've got stuff we've got to do. Clean the skin, put on some protection from the nitrile gloves and move forward from there. But early decon, I'm going to throw it out there again, 85% removal on scene is huge. All right, so when we close the loop on this, and now we're getting to the beyond the PER, we're going to talk about how do we close the loop? How clean is clean? One of the things I talk about too is how dirty is dirty, right? How contaminated is somebody? How effective can we be with contamination or decontamination? How much does it take? Well, how dirty are they, right? So, but how clean is clean? How dirty is dirty? PER, that preliminary exposure reduction, make that a common term, build it into your standards, build it into your operational guidelines, just put it in your way of life that we're going to do preliminary exposure reduction from every scene that we go to. And then we're going to look at the 1850 side, right? When we start looking at who do we use? How are we cleaning the gear? So we want to verify the cleaners. Choose ISPs whose process is third-party verified, right? Are they removing contaminants? What's the efficacy level? Are we asking those cleaners what they look like? Are they testing? Have they done testing? What detergent are they using, right? What detergent are you using? Is there a common methodology that can be used through all that? Match the method to the soil, right? How heavily contaminated are we? Visibly heavy contaminant or unusual contamination is an ISP advanced cleaning. We may want to do some testing afterwards. If we're going into some of those industrial fires and things like that, where we have contaminants that, we've got to look at, are they outside the scope of what we normally see? Yeah, that needs to go to the ISP. It needs to be documented. Hey, this gear was exposed to this chemical at this fire. If it's outside the norm. So we want to document those kind of things. We document exposure, we document cleaning, and if there's verification, we want that. One of the reasons we document that too is it becomes part of that program, right? To where we can say, hey, is there presumption? We're seeing more and more presumption from agencies and jurisdictions that provide presumption of cancer related to, the fire service, related to your time in the service. So documenting that is going to be key to that, to where we can say, yeah, we had the exposures, and we've done these things to help prevent them. All right. So when we talk about decon technology, we talked about it being simple. It really is breaking that chain, but there is technology that comes into play. We want to look at some of that, but the key thing is doing something. Something is key, right? We start there and then we start to build upon it. So what does the modern decon look like? Like, what makes sense? Well, we need a field decon system. We got to have portable spray, rinse systems. The rinse piece should be pretty easy. If you're on a fire scene and you don't have flowing water, then you probably don't have to worry about exposure from PAH and things like that, because you're probably not in close proximity to that fire without some sort of fire stream, right? So we expect the rinse system to be there. But having the portable spray, having the right detergents and those type things are key. So we need the system. It needs to be there, and we've got to have it to where it's common. Right? It needs to be a practice. It needs to be something that we train on, that we have it in place, and it just becomes part of every fire. Every fire scene, just like we establish incident command, we establish rapid intervention, we assign, extinguishment, we assign search, we assign roof. We want to assign decontamination as well, right? There needs to be something that's built into that, our system of operation. Next, we've got to have those sorbent and cleansing wipes, right? We've got to have something in place, not just for the bunker gear. Again, we got to take care of the firefighter. The whole point of that gear is to protect the firefighter. We got to protect them once they come out of that gear too. When we're using those sorbents, when we're using cleaning wipes, when we get to the point where we're actually using those systems, we want to validate the detergents and solutions that we use. We want to use chemistries that are formulated and tested to remove fireground contaminants. We want to do that in a way that doesn't protect or doesn't degrade the PPE, right? If you're using a detergent that was designed for dishes on your bunker gear, you may want to take a closer look at that, right? What is that pH? What is the efficacy there? How much does this reduce the surface tension of water and pull materials out, right? Those type things to look at. It's simple, right? But at the end of the day, that's where the technology comes in. It's no different than using those detergents and water that we've always used. It's just, hey, is there a technological piece that makes this better, that brings it into the data set we have now? And are we cleaning verification? How do we verify clean? Probably in the field, it's going to be tough to verify clean. We're going to have to use that eyeball method, right? But if we have a data set and we're using the right sorbent materials and the cleansing wipes, and then we're using the right detergents, then based on the data set, we're not just looking clean, we know we're getting clean. And that's the key there. Again, for me, all of these point back to, this is one of those things we do for us. This is not a them, this is an us. And it's easy to fix. All right, so just an example here, we're going to talk about the Dahlgren fire detergent. If you're a user of Dahlgren, you already know, you trust it. Dahlgren is designed for chemical warfare agents. It's highly effective in the hazmat world for decon. And we've taken that system and been able to apply it. DSC was just the soap part of decon that we brought into the hazmat world. And based on, fireground operations and looking at, hey, this 1850 standard, that Dahlgren Part A was a natural just solution for it. So it's something you trust. It's not necessarily a new product or formulation. It's just, how are we diluting it down? How are we making it effective? So it's the same stuff you already use, you already trust. We've done some things that help make it more conducive to fireground operations. The great thing here is this is one soap with 3 uses. It can be used on the fireground for that immediate knockdown. It's designed to go into an extractor and to lift the stuff out of the gear back at the station. And it can be used by an ISP to ensure that it does meet that NFPA compliance all the way around. So when we talk about those 4 areas that NFPA was looking at, we want to maintain that pH neutral. Here, the dog and fire detergent, the DSC, the Part A is pH neutral. It's 7.4. That's about as close to the neutral as you can get. It's not even close in that window of getting up to the 10.5. So again, we don't want it to damage the bunker gear in any stage, whether it's the early knockdown phase of decon, the gross decontamination that happens on scene, or in the extractor. So we can go from on scene to the extractor. We dilute this 10 times, and that's what we use for our PER, right? Our preliminary exposure reduction. 10-to-1 goes into something like a decon keg. Just like your water cans on the truck, we can charge it. It's ready to go. No pot life, 10-year shelf life, and we're ready to go. That same product can go into the extractor. It can be used in the extractor of the station. It takes a little under 2 ounces. For that 65-pound extractor, if you're running a small extractor, you can do the math to make that work out for you. Mathing is not one of my biggest things, but it's pretty easy to figure out. We want to target the carcinogens. All right. Like I say, for me, the win here with this product is you already know it. It's verified. We know the efficacy there for removal of hazardous materials. The key thing here is it's a one-stop shop, right? It leads a common methodology and a common approach to the full decon chain, right? All the way down. All right. So we're digging a little bit deeper. I kind of got ahead of myself on that with the PER, but that's the decon keg. It looks a lot like that water can you carry on the truck anyway. It's just got a different type nozzle. It's going to hold 2 gallons. It's a 3-gallon sprayer. We mix that 10-to-1. We charge and storage to 120 PSI, and it's ready to go. 22 ounces of DFD, charged to 120. You can air it up. You could do it on scene, right? Most of the apparatus now have an air line with a chuck where we can charge it. I use my little DeWalt charger all the time to charge mine up. So we're going to apply it to the ensemble, agitate the surface with a brush or scrub the wetted gear. One of the things to think about there is let's try not to use the brush that we used for the trucks to do that too. If we're getting the brake dust from around the wheels that may or may not have asbestos in it, let's try not to use that for cleaning the bunker gear and putting stuff there. Have equipment that's suited and specifically designated for this particular job, right? Then lastly, we're going to rinse, doff, and then wipe down. So that's the PER and a setup. I don't think it gets any more simple than that, right? That charged keg can stay on the truck. We say 30 days, but I've easily seen mine stay charged for 90 days at a time or longer until it's empty. I've never had to recharge it. I only have to refill it and charge it one time. So those things are capable of sitting on the truck for a long time. There's no pot life. Once you mix it up, it's ready to go, and it can stay on the apparatus, but it's easily mixed on the scene as well. All right. So how do we get there? Let's build this up. Let's talk about the response. Make field decon a fireground task. Assign it like you would water supply, right? I remember when the rapid intervention first came into play in my world where I was at, and it was an assignment, and then it steadily became easier and easier to do, to where now those guys, I see them out in the field, and they take that assignment, they work it, right? We need to do the same thing for decon, right? We need to go ahead and set up that PER station. There's somebody on the scene that can help start making that and put it into effect. But if you're in that leadership role, assign that function, add it to your list, put it in your Put it in your to-dos, right? So you know on scene every time it's not an afterthought. Give it a position, it's got a name. The next piece there is once we get it into our operational guidelines and we start thinking about how we're gonna deploy it, we got to have the stuff in place, right? I can tell you nothing is going to fail quicker than a policy or a guideline that doesn't have the tools to put it in place. Pretty simple: soap, sprayers, wipes, bags for the ride home if we don't have a spot on the apparatus, but have a plan. Um, got to have the decon on scene for it to be used. And so it needs to be out there. It needs to be readily available. If we assign it, we stock it, and we run it before doffing at every fire, again, 85% removal. This is the thing we do for us. All right. What do we treat as a trigger? Hey, anytime we have combustible products, anytime I had someone in proximity to products of combustion, that's going to be the trigger. We need to do some knockdown, right? We need to do the decon and not just hitting them down with the booster line off the truck to get the insulation off of them. Let's do the right thing. Go ahead and mix up and take care of ourselves, right? Then immediately decon the firefighter too. That's a piece. And in hindsight, it's so odd to think that we typically take better care of our gear and our tools that we use for firefighting than we do our firefighters, right? That's something that says a lot about what we need to do and where we need to change those paradigms. All right. Again, like I say, for me, there were two things that were key. When I saw rapid intervention come in, I thought that made just a whole lot of sense. The data now shows, hey, it happens on the fire ground, but having that mindset and that skill set to do it is huge. Same thing with this. These are things that we do for us, right? Take care of the firefighter. You're not necessarily taking care of yourself. Take care of that guy behind you, that guy in front of you, and that guy next to you. Right. When we talk about this, we're looking at common barriers. I'm not going to spend a whole lot of time on this, but no time on scene. Yeah, there's time on scene. If we know that 85% number, we'll make time on scene. We do it immediately. We're going to take the time, whether it's on scene or back at the station, right, to do it. So this can be part of building it into the culture, right? We gotta sell people on the why, not just the how and the must. Cold weather decon. Have a freezing weather plan. Do you have a detergent that can flow when it's 18 degrees outside? Maybe you do, maybe you don't. We need to think about that. Do we have waterless wipes? Do we have things that we can at least accommodate and bag up so we get that immediate, right? Even if we can't do the full setup, any link in that chain is going to be huge. The mindset of dirty gear equals experience, make your folks wash your stuff. If you're the guy going in, don't carry it home. Don't carry it around for the next 25, 30 years. If you make it to the end of a career in the fire service, you've seen enough people, the men and women that suffer and die from the cancers that are out there. Let's not increase any of that, right? Let's not make it part of that badge. I've only got one set of gear. Well, that doesn't mean you don't have to clean it. All right, we got to take care of that set. Should we be budgeting towards a second set of gear so clean gear is always available? Yes, but clean wet gear is better than dirty wet gear. So if you've only got one set of gear, you're still putting that gear on if you have another call, no matter what. So to me, that's not a good excuse. Should there be a second set? Yes, but should it be a barrier? Absolutely not. All right, we'll go back through. So what can we do to make a strong plan? Have a written policy and SOP, second sets of gear. Training and drills is important, especially with implementation. Decon should be practice, right? It should be one of those things that we just do. It's not going to be effective. It's not going to happen if we don't supply the people, don't put the cart in front of the horse. Nothing worse than getting a policy, but no tools to do it with, right? Give me the tools I need. Tell me what to do. Get out of the way and let me do it. That's how firefighters work, and that's important here. Medical surveillance, exposure tracking, screening that catches problems early. That's a huge piece of the policy there, right? That's a huge piece that goes in there. And document it. Medical surveillance and documentation are the two things that will help us as we start to verify, yes, we've got an environmental illness that was caused by my occupation. It's an occupational injury. It's an occupational illness. So where do we start? Crawl. Hey, this quarter, the first half of the year, by the end of this year, stock soap, sprayers, wipes, and bags on every rig. Write a one-page field decon SOP or operational guideline. Make gross decon the rule after working fires, right? If your leadership won't do it, in the lack of leadership, that's one of the things I learned in the fire service. If I didn't have good leadership, I stepped up and lead. If you want to clean your gear, right? Make people do it on scene. If you are in a role and a position that you have, that you are in leadership position, make sure it gets done, right? Take care of your people, take care of us. You know, at some point in the walk phase, contact an ISP. Let's do regular cleanings. Schedule those cleanings. Anytime we have that odd fire. Decon and shower within the hour. That's a huge thing. I didn't talk about that earlier, but shower within the hour. Train the drill in the full sequence. You know, as you're doing your quarterly, monthly, weekly training and you're bringing people down for formal training, formally train on how to do a decon. You know, don't wait till they're tired and they've been through that full set of bunker gear and trained inside the tower or done whatever they had to do. Bring them down, talk them through the science, let them know this is something we're doing for us, right? Why are we doing this? We're doing this to protect ourselves, right? For guys like me, there's nothing I ever trained on that was going to help me down the road for something like this. It's all about doing it for those people that follow behind us. Let's let them work safer. That should be important to you. And then the run phase. Once this is up and running, it becomes second nature. Then we can start looking at, hey, maybe we prioritize some of our fire grant funding, our Fire Act grant, and those type things to go into a second set of gear for all our members. Clean cab. You know, how do we design our new apparatus? How do we adapt our old apparatus? And can we institute medical surveillance, right? That's when we start to see that culture change and that buy-in. It just becomes part of what we do. All right, so the key takeaways, 5 things to carry to the house. The hazard is the exposure, right? It is a group 1 carcinogen. What we do is harmful to your body. It will cause cancers, right? We know that. The IARC tells us. The other thing we do know is simple on-scene decon works. So we can remove 85% of what is considered to be the most dangerous, those PAHs, by just doing that simple on-scene decon. Contamination travels. Break the chain. Don't let it get home. Don't let it get to the station. Don't let it get in the cab. Get it off your skin as quickly as possible and keep your gear ready to go. Verify and document. Build a system, right? Make it usable. Gear it up. Make sure it's ready to go. Train it. And that's what changes the culture. Why are we doing this? This is something we do for us, right? This is not about them. This is about us. If you want to look at this further, here's some of the data. Take a picture of this screen. One of the things I know I'm getting close on time. I want to throw this down at the end, that National Firefighter Registry for Cancer. If you are associated with the fire service and have been in close proximity to unburned products of combustion, go online to that registry and get registered, right? That's where the data comes from. That's where we're starting to see it. That's a big one. But all of those things, IFFF and the Firefighter Cancer Support Network, they're working hard. We're seeing a lot of good stuff from them. NFPA is working at it. So the data sets are getting better. It's only going to get better, but use these resources if you can. All right, here's some of the products. We wanted to have them all on one page, but they're up here. This is the dry wipe. If you're in a position where you don't have the ability for the water, can't use the water, the FiberTech is highly effective for that. Dahlgren Decon, if we get into a position where we need more and we're running a technical decon, There's the Dahlgren. That Dahlgren fire detergent is just simply the part A, right? We've added some water too, and it's moving things around. This is that Decon keg. These are all parts of that system, right? This and the Dahlgren fire detergent are the ones that's going to carry us through and do that on scene. Decon can be used in the extractors and again, even for your ISPs. So if you got questions, you can drop them into the QA section there. And I think at this point, that is going to take care of my piece. I appreciate all your attention and time. I hope I wasn't too long over the mark.
Okay, so before we get into questions, I just want to do one correction. This is on me. So thankfully, a member of 1850 or a member of NFPA committees on this that helped develop that standard. The high pH number for detergent to be used has actually been lowered from 10.5 to 9.5. So now it's 6 to 9.5. And that's undiluted. So when you're actually looking at SDSs, I would also encourage you to actually get some pH and test what you have. I've been doing this a while in the chemical industry, and a lot of times I'll actually pH test chemicals and find differences from what's actually listed on the SDS. So I encourage you to do your due diligence on that. And I appreciate that correction. We'll make sure that that's updated in the slide deck before it's sent out. So we have some questions. Go ahead and add them in the chat. We've got one that says, what is the best practice for decontaminating firefighting gear during the winter? Do you use wet decontamination every time you enter or exit the building? Or, let's cut off here, or only when leaving the incident scene? Reggie, you want to tackle that one, and I can add my 2 cents if needed?
Yeah, I think I'll, being in South Alabama, I'm going to talk about my experience there, but there's some data set there. If you're flowing water, as long as we're not going to cause hypothermia, I think the best bet is if I can use water with some type of surfactant, then yeah, we want to do that as much as possible. It all goes back to breaking that chain, right? If I can break that chain, if I have to do a wipe and a brush down because of, whatever environmental circumstances I'm looking at, something is better than nothing. At that point, being diligent as you doff your equipment is going to be huge. And the skin piece, right? Making sure we hit the skin piece, even in those environments. Are we deconning every time we exit the fire structure? No. If you're going to be without your respiratory protection for any long amount of time, then yeah, you may want to go through that section. Again, what we're talking about here is chronic, right? It's not acute. It's not like we get one whiff and it's going to cause issues. These are these chronic effects. These are these long-term low dose exposures that happen over time, right? Your body can slough off a lot of these products. I don't think the fire ground is going to be conducive to deconning every time we come out of a structure and then go back in. That would be overkill. I think that's like wearing a belt and suspenders, but doing the decon at the end of it, right? Once the fire is out is the key.
Yeah, and I'll just add on the cold weather piece. So we haven't specifically tested our dry wipe, FiberTech wipe on PAHs. However, there is, you may be familiar with some U.S. military funded testing that occurred in 2022, specifically looking at cold weather and extreme cold weather decontamination from particulates. And in that effort, there was a variety of different fine to superfine particulates used. And we actually have very good data, not only showing that FiberTech removes those particulates at about an 85% efficacy rate from skin at all temperatures. It actually outperforms as well similar wet wipes. So again, while we don't have any direct pH data, we wanted to keep this as science focused as possible. We do have very good data on the use of a dry wipe in cold weather to remove superfine particulates, which functionally is what soot and the PAHs in soot are. So the next question we have in Germany, fire with inside attack, garment will be stored in a bag. Does it make sense to spray DFD on the garment before packing it in the bag? Reggie, you want me to take this one? Because I know we talked about this a lot yesterday.
Yes, I definitely want you to take this one.
Okay,
we had that conversation, but Corey gave the answer. So
again, we wanted to keep this presentation very evidence focused. This is the hard science. That being said, that is a concept that we are very interested in looking into. it makes sense. What happens, especially with heavy metals on polyaramid fibers, so heavy metals on firefighting gear, those heavy metals, they tend to do what's called matrixing with the gear itself. They almost chemically bond and get into the gear. They become very, very, very difficult to remove even with advanced cleaning. So the concept, the idea, and this is, if you look in like laundry science, this bears out, is that it's essentially the concept of a pre-wash or a stain stick, right? If you get a stain on your shirt, what you want to do is you want to get some surfactant essentially on that stain almost immediately. That way the contamination now binds or chelates, if you want to use fancy words. It will actually get into that surfactant. The surfactant will hold it until you have a chance to get it into the extractor. So based on my understanding of the science, based on the research done on this, yes, it likely would be very beneficial to essentially pre-wet the gear before it goes into the bag with a very good surfactant like the DFD, and that will reduce the matrixing that occurs between the chemical still on the gear and the gear itself, which should allow you to have a better final gear cleaning. If anyone from NFPA wants to fund us to do this research, we're certainly happy to participate in that and prove out this concept.
Corey, I just want to throw something there on the end too. If you're not able to fully adapt to a clean cab concept, but you're not bagging your stuff either, at a minimum, like what would Reggie do? Reggie would wet his stuff down with that DFD once clean before it went back into the cab. And the reason for that is it can't hurt, right? It's not going to make it worse. And if the data set proves that out, we've done another thing to break that link of the chain. So I don't think you're going to hurt yourself by doing that at all.
Yeah, another thing too is when you put the gear in a bag, that gear is off gassing. So it's generally not a good idea to go back and be unprotected and open all that gear up and start pulling it out with no respiratory protection. So at least do that in a ventilated area. Wetting the gear again, right? The vapor pressure of air, well, vapor pressure of water and surfactant is going to keep those vapors down. So just by wetting the gear as well, it's going to reduce the amount of off-gassing that occurs in the bag and then the secondary exposure when you're bringing it out of the bag. We're just applying a lot of hazmat principles because technically we're looking at PAHs as hazmat. So question about dry wipe, fiber type used in post-fire scenes. Again, I kind of talked about that. It has an application, I think, in extreme cold weather and extreme cold weather. Potentially maybe wildland firefighting, which is like the one thing where maybe you don't have a lot of water, right? The water you have is going to be for drinking and putting fires out versus cleaning. So extreme cold weather and then some of those austere conditions, it has an application for skin decon for sure. Okay, we got the next question. Is another one Reggie and I talked about yesterday. We said we're going to get this question. Has Dahlgren system been tested on contamination from electrical vehicle fires? So specifically, electric vehicle fires, no, we don't have any direct testing on that. Look, an electric vehicle fire is a dirty fire. There are compounds that are often present in an electrical vehicle fire that aren't always present in a standard fire, but it's just different hazards. So the same principles apply. The same principles, which is wet things, reduce off-gassing, get the gear off while you keep on air, and then transfer that, as Reggie said, break the chain, transfer that along the process. And then we generally would recommend any electrical vehicle fire, lithium-ion battery fire, especially if it's in any sort of an enclosed space, like someone recharging a bunch of Lime scooters in their apartment and it catches on fire. We would really recommend that gear go through advanced cleaning. Reggie, did you have anything to add on that?
Just that be looking for that. I think the data set is so new on that it's I think I know where it's going to go, and Corey and I talked about that, but at the same time, we're not going to put it out there until the science is there and it's proven. But again, it's one of those things where I don't think there's anything contraindicating it that it's not good for it. Is it the most effective? We don't know. The data set, the science isn't there yet, but there's not anything that I see that says don't use it after that fire. I mean, if it's effective for a regular structural fire, then it's probably at least as effective as anything else you would do after a lithium-ion battery fire. So,
The challenge with lithium ions is it's not so much the battery that produces a lot of the toxic compounds. It's the things that are put in and around the battery cells to prevent them from running away. A lot of fluorinated compounds. You combine those with some of the heavy metals that are present. And again, when things burn but don't burn completely, which often happens because you're essentially burning things designed not to burn, that's when you generate a lot of these kind of very weird, honestly, compounds that aren't fully characterized, and we don't really know the toxicological profile. So one of the things that Reggie and I were talking about yesterday is, in general, you know, if it was me, and it was any sort of like inside attack, again, you know, a plant that makes batteries or a bunch of batteries inside an apartment or something like that, a electrical vehicle fire in a tunnel, things like that. We would recommend that those firefighters actually go through a full hazmat technical decon process versus a post-fire decon process. The Tesla on the side of the highway, right, unless you're up in it, you know, that I think is more of a post-fire decon process. All right, so we've got another one about the registry, the VCU Massey Cancer Center. Firefightersforhealth.org capture the same data at the state level. National Registry shut down during funding. VCU has an interest in following firefighters throughout their career. Was not aware of that. Thank you for sharing. I'll definitely take a look at that website, and anybody in Virginia, encourage you to take a look at that as well. And then the last question I see here is normal, neutral soap are effective. What are the differences in specific soap? The primary difference, so there are differences in efficacy for sure. You know, our soap is formulated to be effective at a broad range and to be able to be used on equipment, on PPE, on bunker gear, on skin, and in a turnout gear extractor. And even on the hard equipment, the SCBAs, the masks, everything like that. There's a lot of products out there, right? You can have a specific product for skin, you can have a specific product for post-fire, you can have a specific product for your SCBA, you can have a specific product for turnout gear. I don't know of many that do all of those roles, and that's kind of what we were trying to get at, to simplify the logistics, simplify the cost for firefighters. As far as efficacy numbers, you know, nothing is really great other than the dry, like the dry CO2 cleaning. That's the only one that has shown a significant efficacy increase over a soap and water method. There are plenty of soap solutions that meet NFPA standards in advanced cleaning, but a big part of that is how the washer extractor is programmed. So you may want to look and say, okay, well, I have to use 20 ounces of soap and 6 rinse cycles and 2 wash cycles and a pre-wash cycle to meet these standards, or do I use, in our case, 2 ounces of soap and 1 run through the extractor, multiple rinse cycles to get all the soap out. And then what does that look like as far as not so much final efficacy, but how do I implement this into my program and not spend a bunch of money or spend a bunch of time? Reggie, if you wanted to add anything to that.
no, I'm good with that. You're all over that one.
All right. So we went a little over time, but it's fine. We've got some great questions, great discussion. You can email info@firstlinetech.com. You can also email training@firstlinetech.com, sales@firstlinetech.com. Really pick a word at firstlinetech.com. It'll get to somebody. Give us a call. Oh, here we go. If you want to contact the sales team directly in your region, and down below, that's our training and technical team. So any questions, we're here to field them. Oh, and one last thing I just remembered. Reggie, you mentioned the crawl stage, right? Write a 1-page SOP. Look, I love Control-C, Control-V. I love copying and pasting. So if you guys need something to start with, we have a few from other departments, some generic ones. And if you want that SOP, just shoot us an email. We can share that. So if there's nothing else, thank you, Reggie, very much. Thank you, everybody, for your time, attention, and the great questions and discussion. Have a great day.